we're all DevOps people. Like, we're the shiny new cool kid on the block. We have a shiny new hat, and we know what we're doing. And what we're doing is basically living the moment, right? To us, containers, cloud natives is not the new normal. It is the normal. We do that. We run at scale. We do things simplistically. We are not going to be bogged down by barriers inside of the organization. We have portable applications that can run on any cloud, and they can run very, very fast. And our working environment, where we spend our time, is in the cloud, in the pipeline. We're developing applications, packaging them, shipping them, deploying them, and all with speed, and all with agility, and all with all our native tooling. And that's great. That's what we do. However, there are some other side of the organization. I'm not talking about old ops, the people that actually run to do servers, but there are the security people. Their hat is a little bit pixelated because it's a lower resolution, but it's also a little bit rugged, rough around the edges. You know, they've been through a lot. We've been through a lot. I'm a security professional. And if you look at the way that security sees the world and what security can do, and any security professionals here, just because I'm going to say really bad things about security. What security people do is they do basically three things. They monitor the network, so basically firewall, for lack of a better term, although there's web application firewalls and segmentations and so on. They deal with servers, so basically antivirus, or privileged identity management, or anything that has to do with dealing with operation on servers. And then there is security operations, you know, things that security professionals need to audit for, they need to control for, incident response, and so on. So that's the world where security people live in. If you notice the world that DevOps is living in, and where security is living in, there's no wonder why they don't talk to one another, because they live in completely different worlds, right? Security is really about protecting hosts, networks, the data center. Even in a cloud, it's really just the data center that somebody else has built. And our world, the DevOps world, is in the development, in the packaging, in the shipping, in the deployment. So there is really very little overlap, natural overlap, between what security is doing and what DevOps is doing. And yes, there are some things that we can do. There's some code scanning that happens on the development side, and there is some operational controls and even network controls that can happen on the deployment and shipping side. This is a gross simplification of what is going on. But if you look at the stack, this is where security lives. And that's where they're comfortable living, right? Security people are happy when everything is on-premise and they can implement the control plane on every single aspect of the application deployment stack. So it starts with deployment, the packaging, the data center, network host, and so on. And then strange things happen about, I don't know, early 2000s. We started to talk about cloud, and we started to get that really neat structure that security people like a little bit discombobulated, right? We kind of outsourced our network and our data center to cloud operations, still maintain access to the host. You know, we have instances, we have VMs. And security people were like not too extremely happy about that, but they managed, right? Because the cloud providers gave us the tools in order to do what we could do in the data center, but just to do it in the cloud. When DevOps really started to come on board as a practice, and especially with the advent of containers and the ability to run those microservices in a environment that is separated from the rest of the data center, host network, and so on, security people start to get a little bit worried. Because now we have something called like the thin host, if you heard that term. The thin host is where we are basically stripping down an operating system just for the purpose of running containers or running functions. And it's usually not managed by anything. So your AKS, EKS, GCPs of the world, they all have their own implementation of the preferred thin host that runs those containers. Security people really do not have login to that. You really can't run your antivirus on that host. You really can't run your privileged identity manager on the host. So we are starting to see how the loss of control starts from the data center side, permeates through the network, and now goes into the thin host. But actually, most of security people will actually not be totally wigged out by this. They do start to get a little bit more antsy when you're going into the container as a service environment, right? Your ACIs, your Fargates of the world. Because now you're taking your whole application deployment, your whole container, and just throwing it over the fence and say, OK, you run it. You basically run it. You need to keep the uptime. You need to have all the controls. We can do a little bit of controls around the network, but there's really no way to implement good application security controls inside of your ACIs and Fargate environment. So security is really worried. Now, I do a lot of security conferences where I talk to security professionals. When I start to talk about CaaS, they just, I don't know what to do with this, right? How do I audit? How do I do retention of incidents? How do I do the forensics on that environment? How do I audit something that could be gone in 2 minutes by the time that I look at it? So there's a lot of operational issues in that environment that deal to do with how to execute the required security controls in those kinds of environments. And when we move down to functions, like all bets are off, right? They're going to need some really mental health counseling, because now you take basically somebody's code and you throw it way over the fence and you just run it, and it just runs. And it runs for like 2 minutes, and then it dies, and by the time that it dies, you really don't know it existed because you need to clean up because you don't want to pay for the retention of the data, so there's no record of what happened. Wow, that was a long sentence. So in the environment where we're operating, it's not just that security is losing control. There is actually a real void in that environment. And that void between packaging something and then deploying it and running it is something that the universe hates, right? The universe hates vacuum. And we have a decision to make. What are we going to fill this vacuum with? We can fill this vacuum with, or just allow it to be filled with the bad people that will be happy to take any vulnerable code that we might have in our development, in our artifact, any insecure configuration in our images, any insecure configurations in the way that we roll out functions and containers, and that would lead to application misuse, which is a really nice euphemism for you're going to get hacked so bad, and to data theft, and basically anything that could go wrong in an IT department. And there's really nothing that anybody can do about it because we just don't have, the traditional controls don't really operate in these kinds of environment. It's not anybody's fault, it's just that reality kind of took a sharp turn and security was left stranded and just didn't know what happened anymore. So that's one way that which we can fill the void. The other way that we can fill the void is by doing DevSecOps. And yes, there is a picture on the internet of a hat that says DevSecOps. I was very surprised to find that. And the way that we do our DevSecOps, the way that we get all that stuff together is basically two mindsets that we need to share. We need to share them between security people, and we need to share them between DevOps people. And these two mindsets are shift left and shift up. Now, shift left is more uncommon. Shift up is something that is just starting to grab hold in the industry, and that is, how do we secure those, the execution and the running of those environments if we have really no way to implement those controls. So, what does shift left mean? Shift left mean as a mindset is that if you are developing an application in the left side, or your left side, of the pipeline, that means that we need to have some security awareness in mind. There's tooling that can execute those things, but it really requires us to have the mindset, and that mindset needs to permeate throughout the entire organization. So, if you're writing code, write code with security in mind. It doesn't mean that you have to be obsessed about security. It doesn't mean that it has to consume every fiber of your being as you are writing your code. But whenever you write a module, a function, a procedure, kind of ask yourself, well, what happened if this? How can this get misused, right? And yes, there are there's tools that can validate your code for like SQL attacks and so on. But most of the intrusions are just shortcuts that we take as developers. So just have some security mindset around that. If you are building images, use the leanest, most efficient based operating system. And I can't stress that enough. The biggest issue is just bloated images that are just a cesspool of executables waiting to be hacked. The leaner the image, the better. It is okay to basically run like apt-get or yum remove in your image. That's totally okay. Everybody does yum add or yum install, but it's okay to remove stuff. And if you start from a lean operating system, if you start from Alpine, if you start from Debian Slim or something, you have a much better success rate of actually producing something that is more in line with security practices. If you are going to have two components communicate with one another, don't store the keys or the passwords in your image. Nobody does that, right? And then think about, what is the user context, right? Everybody likes to run as root because then you don't have to change file ownerships, but that's probably not the right way to do things. So these are all common sense things. I'm not telling you anything new. And then choose open source components that are completely free of vulnerabilities. And that is, of course, impossible. Now, this is where a lot of the hang-up comes up, because if we need to now collaborate with security and start to have security reviews of our finished artifacts, images, or functions, this is where things get a little bit testy, because and from my conversations with developers, it's like, well, they're just going to tell me I can't use a component, or they're going to tell me that there is a vulnerability there, and I won't be able to deploy it, and it's going to put my project behind, and I won't be able to deploy the application. That is not necessarily the case. I think security is actually your best friend in this instance, because what they can actually do is they can mitigate, a lot of times externally, some of those problems. So if there's a component in your environment that is susceptible to some sort of HTTP-based attack, but you really need to use it, well, security have the means to maybe protect it externally. There are web application firewalls. There are actual firewalls that can deal with it. So there's no reason to hide behind, security is going to stop me, because security, if approached correctly, is actually an enabler. Now, security people are busy. They might tell you to go away. You might need to come back and actually insist and work with them and ask them, well, how do I mitigate it if I really need to have that component? Or can I get a security exception, which security people are really happy to do as long as there's good business reason for that. So shift left doesn't mean that we have to take all the onus on ourselves and implement security, and we are the one-stop shop, and if we can't secure the code, it can't be deployed, right? It's a starting point for collaboration with security. Now, the more interesting thing, at least for me, is shift up. Now, shift up is really about securing the operating environment where you're going to run your payloads. And that needs to be closest to the assets, right? Think about reduction of the attack surface. If we have an application, ask yourselves, what is the worst thing that can happen? What if I am developing an image, if I deploy this image, if somebody takes over this image, what's the worst thing that can happen, right? Are there components there that are just there and the application doesn't need them and they're just waiting to be exploited? Net maps of the world and pings of the world and things that can use for reconnaissance into other areas of the environment. Can I make sure that in my application we're not opening the door to add any other components post-deployment, right? Because we don't have the ability to audit containers the way that we did operating systems, and there's really no way to safeguard the addition of those files outside, wrapping the container with external security tools. If you're designing an application, make it a microservice. A microservice should actually do very little. So one service, one user for one purpose, it's going to make the administration of security controls a lot better. And again, if you are thinking about ways in which your application can be misused, what happens to a compromised container? And can we design our application in a way that can make a compromised container very, very frustrating for an attacker to exploit? And if we do all that, if we package our artifacts in such a way that they contain all those security principles, then our security becomes very, very portable. And we are filling the vacuum. We're not really filling that particular vacuum, but we are making sure that that vacuum is not exploitable, because we are now taking the security controls that we used to have in the data center, in the server, in the network, and transferring them into the deployed application code. Nothing is more important than doing those things when we're working with serverless environments. So those are hardened eggs, I guess. And we need to make sure that everything that we deploy in a as a service environment, whatever it is that as a service is as ironclad as it can be. So that means that if you write an application code, make sure that that application code is reduced of risk by the selection of components and the programming principles. Make sure that if you are using open source libraries, you do make some intelligent choices. It's very easy to find out what is the risk profile of an application. You really don't need a function scanning tool to do that for you. If you're going to use an application, a simple Google search or whatever is going to allow you to do that. And then, don't store sensitive data, hard-coded keys, credentials, and so on. Another thing that we need to do is reduce the risk in deployment, right? Because those functions, whichever cloud environment, will need some permissions. They need a trigger. They need to be active for a certain time, and how we invoke them, and what is the trigger to invoke them. All those are elements of control, and one of the things that security needs to do is to demonstrate control. So if we can demonstrate control over those functions, we'll be able to then demonstrate that we are adhering to good practices as far as the security of those controls. Now, what are the controls that we're trying to avoid, right? If you're a security person, what are the things that kind of wake you up at night, and what can you bring, and that is where the collaboration starts to come into play, what can you bring to your security professionals as a way to meet them halfway and kind of offer them solutions and not just problems? So the things that security people are afraid of is, rogue deployments, like your, I don't know, Bitcoin miner container that instantiates in your Kubernetes cluster and you have no idea that it started. Malicious code injection, so doing the same thing but in a running workload. Administrative action, compromised credentials, theft of strings and passwords, network connections that we can't control, and all these 0 days unknown vectors. What is the anticipation that something bad is going to happen? Now, all of this can have DevOps type solution. They're not going to be completely the DevOps type solution, are going to address every single security control, but they are going to be going a pretty long way towards having some positive intent in solving the security issues. So a lot of monitoring, a lot of inventorying, image trust. If you can sign an image, sign an image. If you don't allow access to too many people into your kubectl, if you can use the permission controls inside of Kubernetes, if you can use the permission controls inside of the operating system, resist the temptation to start attaching to running containers and solve problems on the clusters. And if you really have to do that, then taint the node so it doesn't get instantiated somewhere else, because you can't prove. There's no audit trail of what somebody was doing inside of a container. Secure secret distribution. Don't use just hard-coded stuff in your artifact. If you are going to model the connectivity, at least have an idea of what that should look like, and not just say, well, my container needs to run on port 80, so I'm just going to have every other container be able to connect to it, because that is an opening for propagation of security concerns throughout the environment. And then if we can deploy with some built-in preventative controls, which means that our application should be resilient to things like trying to start it with the wrong parameter, or do anything that is outside the guardrails of what the application should do. And that will really bridge the gap. So don't rely on security to be implemented on the host and on the network level. Don't leave security to the very end, because then you're going to have an artifact that's going to live in that vacuum, and then that's an invitation for bad things to happen. Your deployed application, you've got to treat it as the last line of defense. It means that if you said, well, I'm running behind a firewall, or I'm running on a host and there's antivirus on the host, or there's host controls, those are not going to happen anymore in those as-a-service environments. And we know that the community component, the open source components, that footprint is only going to increase, and it's going to be your responsibility to use the right components, but sparingly, so that you don't overwhelm your artifact with code that really should not run. And then understanding the application is vital for protecting it. Now, you understand your application. You understand the application architecture for the most part. Security does not. And security being involved earlier in the design process is going to allow us to have, first of all, a lot of confidence building measures around the collaboration between security and DevOps, but also some good insights as to what really needs to happen in your environment, so that we can bridge that gap, we can fill that vacuum between packaging and deployment. So I'm going to get off my soapbox a little bit and give you some free stuff. Free stuff is always good. So Aqua is a contributor to the community in areas that will allow you to shift left and shift up your security. There are free tools that are available. You can assess your images at time of build with these tools. You can discover and assess your Kubernetes environments. And you can get a lot of insight into really whether or not you have a security problem. So hopefully that will give you the confidence to engage with security if you already pre-assessed what your security stance is. So this is the output from the Aqua microscanner, which is something that can be embedded in a build. It gives you a CV identifier, which is a vulnerability identifier from the National Vulnerability Database, a description, 2 opinions. One is the official kind of NVD data. That's what security people are really, really interested in. But then it also gives you what we call the vendor score, or the maintainer of the package. And a lot of times that's where you really want to go, because that will tell you what is the programmatic impact of these kind of things. Sometimes it's a GitHub discussion, sometimes it's a group discussion. So it's really interesting how you can get some of those insights into the impact of a vulnerability, and then always, if possible, give you the solution if it's a backported solution by the maintainer of the package, or if it's a solution that is require you to then upgrade to a better version of that component. We'd really invite you to use these solutions. And KubeHunter, which is the Kubernetes discovery solution, is a way to assess the security of your Kubernetes clusters. If somebody did a scan of the network, and can they get information about your Kubernetes environment? Can they find entryways into managing your Kubernetes environment? Is your Kubernetes environment up to the standards of how to deploy applications? So hopefully, the images themselves plus the runtime environment, as narrow as it is between images and Kubernetes, should give you the basis for discussion with security and starting to have the conversation as to how to even bring that better into the organizational standards. So please use these things. These are the links. I'm going to leave them for a little while here. You can use the microscanner embedded in your image. So that's actually a sample from our GitHub page. And KubeBench is the Kubernetes assessment tool for standards, and KubeHunter is the discovery tool for Kubernetes. So that's my talk. I hope that I wasn't too lecturing to you. It's always easy to kind of tell people, you're not doing a good enough job, you've got to be more secure. But the end result is that everybody needs to be reasonable. So I hope I was able to be reasonable with you. Thank you very much. I can take some questions.